Hey, and we're live with today's interview. Yes, there's a bit of a feedback. So today we have Klaus Iglberger as a guest, and we're going to speak about his talk, which is titled The Real Problem of C++. And I think we get started with a short introduction. Klaus, what do you do with C++?
So then, first of all, hi Jens. Thank you for the introduction to this video, this invitation. I'm super happy to see you again. Yeah, and I do not envy you in this time preparing meeting C++. That's probably the most busy time of the year for you. So what do I do with C++? I do assume that many people know me, but some might not. So for the last 10 years, probably more, I've been playing the role as a C++ trainer / consultant. So I pretty much talk about C++, not every day, but most days of the week in training classes, at conferences, so in public talks, in invited talks, etc. So I do a lot of C++. I don't write so much C++. I rather talk about C++ nowadays. So this is indeed what I do for a living. People can hire me for training classes. People can hire me to consult them about C++, do code reviews, architecture reviews. Yeah, sounds like a boring job, but actually it's quite interesting indeed. So now I don't hear you. I'm not sure what happened.
Yeah, I muted myself. So
Good.
exciting things about your talk. You're giving a great talk this year, very popular.
It seems to be reasonably popular indeed. So I was very happy that I got the email from Meeting C++ Under the Sea, not Meet, C++ Under the Sea from last week. And apparently approximately half of the people in the feedback said that my talk was the defining talk of the conference. That made me pretty happy. So usually I talk about C++ software design. I talk about design patterns. I talk about software design principles, architecture, because I believe this is a super interesting, pretty important topic. So few people talk about this. This year, I decided to talk about something different, something that just kept annoying me for the past years, something that is related to the C++ safety discussion. So talking a little bit about what I will do in this talk. And on the right, people can actually also see the abstract. So many people complain about C++ nowadays. So many, yeah, and especially about the lack of safety. Now, I've done C++ for so many years that by now I really don't understand this discussion anymore. So I understand part of the discussion, but I do not understand the criticism about the language. If you do want safe C++, it's amazingly safe. We have everything in the language that you need to really make this almost 100% safe. And that's what I show in the talk. So I go through the big memory safety issues. I think I'll talk about bound safety, type safety, initialization safety, lifetime safety, and even undefined behavior. And I show that by very simple means, all these problems suddenly go away. Really, all these problems go away. And it's not new solutions, but it's so old solutions. Some of them have been in the language since the very beginning, like no raw loops. The statement that John Parent gave in 2013, which has been true since pretty much the beginning of the language. So the real problem of C++, from my point of view, is not the language. From my point of view, the problem is the use of the language. And so that makes it a people problem. And this is what this talk truly is about. So I think we lack in many different things. We lack in the language too. There's so many things that you can improve and that you have to change, but you definitely have to deal with other issues as well. So let me perhaps tell a war story about something that happened to me approximately 2 years ago. Approximately. when I was doing a book review. So the book review was about one of the old books, one of the books that have been around for a decade at least, and probably much more than a decade, and it was upgraded to C++23. So I was actually quite happy, quite honored that I was considered a reviewer, and so was reasonably motivated to get started. Now, what I got was the first chapters, so chapter 2, 3, 4, 5, 6, etc., which I reviewed accordingly. So it started to turn bad in chapter 7 of this book. So I think the chapter, I don't know how to tell you more, it pretty much was about memory management. And so it started pretty much with a sentence, sometimes C++ is driving without a road. So, and in that context, in chapter 7 of the book, I found this to be absolutely misplaced. Absolutely misplaced, because if somebody wants to learn the language, should not in chapter 7 start to believe that it's a pretty bad idea to use the language. And so I wrote the according review, and I said that from my point of view, this chapter was entirely wrong. That first, it was way too negative. And at second, of course, it's bad to show in chapter 7 of a beginner book pointers and pointer arithmetic. And only as a side note at the very end of this chapter, how to do it today. That we use smart pointers and that we do not do pointer arithmetic, etc., etc. So it just was plain wrong from my perspective. Plain bad teaching style. And so I pretty much argued that the entire series of chapters should be changed, that this should be much later chapter, that first we should teach the things that are safe, that are good, that are fast too, so that it's time to rework this. So, of course, I did not expect that this would happen, because nobody rewrites an entire book of 1,000 pages. That is just too much work. But I actually expected to make an impact. So an impact I did make. I was removed from the review. So that kind of left a fundamentally bad impression on the entire industry. So if publishers do actually not care about how things should be taught and what is good today, then we really have a serious issue in the entire community. So actually, I should explicitly say that it wasn't the author. The author understood, but said that the publisher wouldn't give him the time to actually rewrite everything. That he would do it, but he could not. But well, entirely it was entirely focused on money and making money. So that pretty much started my thought: what is going wrong in our community, specifically in C++? And so I more and more discovered that teaching C++ is just really bad from my perspective. I'm not talking about other trainers. No. That's not the point. But if you do look at books that we currently that are still sold, successful books, then so many of these books are actually not adequate anymore. And so, of course, people learn that old style still after so many years and use the language in a way that just isn't safe, that just isn't good. Sometimes it's not even fast. And that's the problem, the real problem of C++, from my perspective. And this is what this talk is hopefully trying to summarize. How should we program today? Why isn't this the default? Because it's simple, it's safe, it's fast. Why isn't this the default? Okay.
So you're trying to make the connection between safety and learning C++, which is interesting because our keynotes are exactly about these things.
Oh, good.
And
then this actually fits
safety
well.
is one of the big topics this year. We have a lot of talks on safety. And I've just learned we have one more.
Yeah, it's a hot topic, and I believe that we had good talks about this before, but unfortunately, from my perspective, we had so many talks that started to be very defensive, like, oh yeah, we have to fix the language, it's not good enough. I have a perfectly different opinion. My opinion is we have a very good language, a very safe language. We just have to use it. We have to use the features, we have to use the style that has been bit practiced for the last, well, decades already. but it's not used yet. And people still complain about the problems we had 20 years ago. That's not okay. Especially it's not okay because C++ is still compared. So if it is compared, the old C++ is compared, not the new one. Yeah, the thing we do today. And that annoys me greatly. So perhaps another war story, a short one, because of course social media is part of that too. And I'm really annoyed by all this misinformation, this information from people that don't know C++ apparently, but still talk about it. So how long was it ago? Perhaps a month, 1.5 months ago, in a LinkedIn article, somebody actually claimed that it's definitely better to use Rust in this case because C++ doesn't have a standard. Whoa. So somebody had already answered. So Chris Rind actually takes the task to really talk these people down. But he does this pretty well. But really, that this was a shock moment. Somebody really claiming that C++ doesn't have a standard while Rust has. That's turning the world upside down. And so this is something we are fighting today. This misinformation and this total nonsense, this incompetence and ignorance of other people pretty much destroy part of this industry. I don't like this at all. And this is why I started to talk against this too. Yeah, that's what this talk is about too.
It's always been fun about C++. Java
that's true. But there is the good fight, yeah, the discussion how to make it better, yeah, choosing the right path. But then there's also this, from my perspective, rather new fight against people that just don't know, that really have no clue. And that's annoying.
Yeah, I understand that. So, what have you learned about C++ from working on your talk?
So I actually started to think about which solutions do we have. So which safety-related solutions that might be new, but that also might be old. And I realized that many of the things that we already have and have had for, well, sometimes since the beginning, are just not used. Not used enough, I should say. Not used enough. I think while working on this talk, while preparing this talk, I've realized more and more that we could have a very, very happy life. We could have a language that is considered safe, but unfortunately it's not. Yeah, so I think this is the thing that I just realized more and more while preparing the talk.
Now, you're also well known about software patterns. You usually speak. You already mentioned that. And so you're also giving a course. So I thought we quickly talk about that.
So this is my pet project, my pet topic, I should say. So in 2021, I published a book entitled C++ Software Design. This book was already based on a training class that I've given a couple of times before. But since this was quite successful, I wrote this book, and I pretty much in these training classes talk about the book. So in this training class, 3 days, you see this at the bottom, I pretty much talk about how to structure and how to organize software in a better way. For this purpose, I talk about classic design patterns. So I talk about, for instance, the visitor pattern, the strategy design pattern, prototype and bridge, and a couple of those classic Gang of Four design patterns. So these patterns have been around since 1994. This is when this Gang of Four book was released. But since then, many things have changed. Many things from an implementation point of view, but patterns are still around. The patterns truly are everywhere. And this is one of the things that I teach in this talk, in this training class, making people realize that these patterns really are everywhere, even throughout the entire standard library. You just have to realize that the pattern is used. And so I talk about the patterns, the classic form, a little bit, the modern form, but then also how to apply them properly, when to use them, what the advantages are, the advantages, but also the disadvantages, because there is no single pattern that can solve all the problems. So I compare them, I combine them at some point, because this makes everything even better. And then hopefully people have afterwards something like a toolbox that whenever they have a problem, they can reach into, grab the right pattern, and apply it as a good solution. Perhaps to advertise it a little more, again, last week at C++ Under the Sea, I've given this as a one-day workshop. And so my impression was that everybody was quite happy. Actually, it was one of the very, very, very rare workshops where people even actively followed my special actions. So sometimes I sarcastically say hooray, and everybody was applauding in the course. That was fun. Although everybody knew this was bad code initially. So it was a pretty entertaining workshop indeed. So I tried to do the same thing here for 3 days, which is just so much more complete. You can talk about more patterns. I can talk about more implementation details. So for instance, big highlight in this training is type erasure. I will talk about type erasure. I will explain how it comes to be, what we solve by means of this. And I'll also talk then about the implementation details, the different ways to do this and to do it better. For instance, okay, I'll show a simple version, then I'll show a version without dynamic memory, then I'll show a version where virtual functions are manually implemented to speed up performance, etc., etc. So, meaning, if you have 3 days, you can also talk a little bit more about how to do these patterns properly. Yes. So I believe this is going to be a pretty interesting course indeed. And from a pricing perspective, I actually believe this is going to be not bad. It's rather on the cheap side. So really recommended for everyone who is interested in learning a little bit about these patterns, wanting to understand a little bit how to organize and manage software or structure software in a better way. I believe this is a good investment indeed. I hope so.
Yeah, I think so. So what about patterns? What is your favorite pattern?
Oh, that is a good question. Difficult one though, because I just said there is no perfect pattern, no pattern with just advantages. So if I would have to select one, that would be a little difficult. So I usually would answer with I have 2 favorite patterns. So most definitely, I do like this type erasure pattern because I'm amazed by how easy it is actually to separate concerns between some abstraction and some implementation. I think this is a wonderful modern way to organize the software with loose coupling. However, type erasure has the advantages of classic object-oriented programming and a few more, but it also has disadvantages of object-oriented programming. So you can add types very easily, but not operations. So meaning you need a counter pattern that can do the other things well, and that would be the visitor pattern in a modern form of stud variant. And that definitely augments or combines well with type erasure. Sometimes you need the one thing, sometimes you need the other thing. And so in this training class, I will show both. I'll of course also explicitly compare them with examples and code programming exercises so that people realize, okay, in this situation, I should use this solution, this pattern, and in the other situation, I should use the other one. And then I believe this is a good general selection of patterns. Yeah? So these 2 would be my favorites. It's not special patterns, though. I should say that. I don't think this is something that is exclusive to certain situations. I think these 2 are very general. Can be applied to any code base, any application, whether it's performance relevant or safety relevant or something else. I think this is good, basic, always interesting patterns.
What about the opposite? Any pattern you dislike?
Oh, also, I do have patterns that I kind of dislike. So that indeed are a couple of Gang of Four patterns where I myself never found real application. It's maybe because I never had the example where it might have been interesting, but I just never really had the application. So, for instance, the media pattern was something I never could apply productively. Interpreter was also something that I never really used productively, and perhaps even flyweight, which theoretically makes sense, but even that I never really used productively. But this is not dislike. This is more like I've never really seen the big use. I feel it's a niche solution. The more dislike is indeed this discussion about singletons. Yeah, also one of the patterns described in the Gang of Four book, but it just is not really one of these patterns. I've given a talk about this at I think it was C++ on C 2022, a talk where I said actually single is not really a design pattern. It kind of serves the opposite. It doesn't give you a good design, it destroys a design. And so I feel like it's an anti-pattern indeed, an anti-design pattern. This is what I rather dislike. Yet I believe this is an answer that many people might have predicted. It really is the one awkward pattern. And even Gang of Four said afterwards that they kind of regretted to having added this to the book. It's the odd one out to some extent.
Yeah. So I don't have that question, but I have this question in the survey. And
okay.
here you see singleton is on the second. So people cannot. This is single choice.
Yep.
You literally have one vote and that's it.
Mm-hmm.
People like every second, like not every second, but like the second place is singleton.
So this the question was, what do you use, or was the question, what is your favorite pattern?
This is what is the favorite pattern?
The favorite pattern number 2 is singleton. See, this is a little scary, especially interesting because the third from right strategy is top 4, I would argue. However, I claim that people every single day, in every piece of code that they use, very likely use a strategy pattern. It's everywhere. It really is everywhere. People just don't realize it. So even a standard vector uses a strategy pattern because it allows the injection of its allocator. So implicitly might use it. Yeah, they might just not actively use it. Yeah? Not everybody injects an allocator. But strategy is everywhere, and so way much more interesting than a single. Okay, factory is kind of more obvious. Okay.
So this is the multiple choice, I believe.
Okay, this is which classic design patterns do you use? Okay, this is multiple choice, right?
Yes.
Okay. Okay, now unfortunately, yeah, now I see that. So, okay, interestingly, still strategy is not rated very high. People don't know that strategy, what strategy is, I believe. And now I'm looking for decorator. Okay, decorator is somewhere in the middle, this bluish green turquoise. Also not rated very high. But also here, I'm pretty sure most people use decorators, even without knowing it. And one of the reason is that I believe we have misnamed this pattern, no, the use of this pattern very often. There's something I will eventually also give a talk about. But for instance, in C++20 ranges, we have these adapters, range adapters. From a design pattern perspective, those are mostly decorators, almost all of them, not adapters. And so as soon as you use ranges, you use decorators everywhere. Yeah, that this is the dominating design pattern in this context. Adapter is rated a little higher. Now I see it. Fifth from left, the purple one. Okay, maybe a naming thing. Okay, now.
But you were right about fly rate.
Yes.
So
There's probably good use cases. I didn't realize, didn't have one in practice. This is just because I, of course, have special certain applications, not others. Now, it makes sense from a theory point of view. But mediator, for instance, this is almost the lowest one. Okay, memento even in lower. And interpreter, this is the ones, the two of the ones I am named.
yeah.
I really don't have a real application for them. I don't. Others might.
Yeah, I think they're more niche.
Yeah. Interesting iterator, the blue bar between interpreter and mediator. Also here, pretty much everybody uses iterators. It's the thing in the standard library, the STL part at least. So I believe that should be way higher, definitely higher than singleton. That makes it a little scarier, indeed.
Okay. I wanted to pick your brain on something. What's your view on arrays of structs? So generally going more cache friendly than object orientation.
Yeah, which is quite popular nowadays, and not just today. So this when I was still doing HPC at university. So while I was doing my PhD, I worked with computing centers, etc. So at that point, array of structures was already quite favored because of performance. So many people bring this into combination with data-oriented design. So design your data such that the algorithms can very effectively use the caches. As few as possible data has to be loaded. So that's pretty much what I usually put into contrast with object-oriented programming, the data-oriented design. So I've not used it myself in a big scale project. And this is why everything I say should be taken with a grain of salt. But I see the positive aspects really just in the performance part. So performance is definitely improved, absolutely, because the performance characteristics are just supported as well as possible. I do see problems in the maintenance part, though. I know that some people claim that maintenance is great, but I don't think so in comparison to the other paradigms. If you do change something, and really fundamentally, like changing the data that is associated with an object, and you change a lot of code. You touch a lot of code. And that's exactly what you usually try to avoid in design. Change should be simple. Change should be straightforward. And if possible, we should change things in one place. And that's where this data-oriented design actually breaks. You do not just change things in one place. You'd have to change things in multiple places. And that takes time. That is error-prone. That might break things. And so for a large-scale project, I don't think this will work well. But I don't think that a single paradigm is reasonable for a big project. You should always combine the paradigms such that you can benefit from all the advantages. So on a smaller scale, a small part, I think this is just amazing and the correct thing to do. Then once in a while, you can also throw in functional programming, because also this works super well on a smaller scale. This is pretty much what the algorithms prove. But on a bigger scale, the scale then when we then grow into millions of lines of code, this is where object-oriented programming really shines. But this is not the scale where we think about performance anymore. This is where we think about organization. This is where we think about code organization, team organization. Yeah, so I think this is for the smaller things, not for everything. And as soon as people kind of get this idea, I believe, yes, this is a pretty good addition to any code base. Pretty valuable indeed.
Yeah, I have similar views that it is something which is a useful tool.
Mm-hmm.
And of course, when performance is very important for you, then that's the way to go.
Indeed. But as I said, not everywhere. but in the 10% of the code, that makes up for 90% of the resource consumption. The 90-10 rule. I think as soon as you have this on the radar, you can use this wisely.
I mean, I saw recently the keynote from Vittorio Romeo at CPP.
That was a good one.
He's like 100 frames per second, and you got a cap about performance and a bit more than
Indeed.
than when you do object orientation. Anyways, is reflection going to make it easier to implement type erasure?
I think so. I've not tried it myself because it's not really there yet. So I didn't upgrade my training classes. If people cannot use it productively, then there's no point. But this was actually demonstrated already by David van der Voorde in his 2024 keynote at CPPCon. In the last couple of minutes, in the last 5 to 10 minutes, he actually demonstrated that he can use reflection to generate a type erasure wrapper automatically. I believe this is impressive because this is exactly what is missing to make this technique, this design pattern more mainstream. This is what people complain about. Oh, it's an amazing pattern, but I have to write this wrapper class. I agree entirely. This is a little bit of a nuisance. Now that since I've done this many times, I think it's just a little bit more work than if I just would use the good old inheritance approach. But still, I would like this to be generated automatically. And reflection probably will help quite a bit. I don't know exactly how much. Okay, I'll have to experience this myself, but it will help, yes.
Yeah, so quick feedback to the audience. If you make your questions really long, I cannot post them. I have like 200 characters and that's it. So keep them short and have a question mark in there. That helps. So
any question from the audience is welcome. You can also summarize them if you want to. Or can. It depends on the question.
Well, here's an example of a question which doesn't fit into the tool. In the embedded space, I see better and much more user-friendly libraries like simple BLE Botan or maybe nlumen JSON. And also Qt Core is much more user and beginner-friendly than the SDL. I wonder if not more safer and beginner-friendly core library is needed that scales to small and larger systems.
So the beauty about C++ is that you can choose your own libraries, your own tools. I think this is a huge advantage. And so if there's a library that you consider better, there's something in the standard library, use it, absolutely. To just give another example that is quite popular nowadays, people complain a lot about the C++20 ranges library. This is what so many people have talked about, the deficiencies, the flaws in C++20 ranges. And I totally admit there are a couple of flaws indeed, which are unfortunate, but okay, that's how they were designed. But if you don't like them, at least 5, 6, perhaps even more people have written their own ranges library. And those, from my point of view, are really good, might be superior to the C++20 ranges implementation indeed. So you can just try them out. Yeah, you can swap standard ranges to any of those libraries, and you might not even see a difference. So let me highlight one that I personally like and feel is just really good work. So I really like the Flux library from Tristan Prindle. He's currently updating this to Flux 2.0. And I don't know exactly when the time is that he will update this, so also completely in a repo. But the 2.0 version seems like a major step and really feels, well, simple, user-friendly. Error messages are better than in the standard ranges. It's really fast. The compiler can optimize combined algorithms really well. And yeah, it's a really good package. So feel free to just use something else. There's no need to use, nobody's forcing you to use something from the standard library. Yeah.
Yeah, I think that's true. So it's unfortunately, like, usually we have LinkedIn, which makes these questions from the audience a bit easier, but LinkedIn seems to be like totally down today. So as this is like such a hot topic,
It is.
what is your answer outside of user safe features?
So if you have a project that is entirely defined by safety, nothing but safety, then I think it's definitely reasonable to consider a language that gives you the safety for free. Yeah, a language that focuses on safety is giving you the one thing that you need. You should realize, though, that of course you're buying into disadvantages as well. So if you're locked into these safety features, you cannot express everything in every way you want. And that, of course, can later lead to, well, then workarounds. So I believe C++ can be just as safe, but you will have to do this yourself a little more. The language does not protect you as much, but it can also give you the other advantages. You have more freedom to express yourself. You have many more approaches. You have a really thriving ecosystem, many libraries around that. And so I believe C++ actually fits very well in a safety critical environment. Very well indeed. But still, there's a good reason why there is languages that are focused on safety entirely. The other aspect is people again. Yes, unfortunately, not everybody is a C++ expert. And you will never have a group of just C++ experts. And of course, then there's the risk that in C++, safety concerns are introduced much more easily. True. But I do not believe that if you use any other language, you'll have just experts. No, you'll have exactly the same problem. The language makes it a little easier to force people into the safety thinking. Good. But you will still have the risk that people mess things up. Because a safe language, a safety-focused language is not automatically safe. It's also one of these misconceptions. Therefore, you might still have to invest into people. Yeah, the education of people, the hiring of good people, which is another story that I could tell. And you'll have to invest into your people, not just the language or ecosystem. Okay.
By the way, are you like planning a second book on patterns? Because I know that you had material from the first book.
I
And
am thinking about this. I'm thinking about writing a second book for real. I've not entirely decided that it will be another pattern book. I think there are other topics that they can also write about that might be a little more important. Point is, in this first book, I have already talked about a lot of very important patterns and topics. So there are not so many super important things that would go into a second book. This is why I believe another topic might actually be more important, more urgent, I would say. For instance, a book about safety. That might actually make more sense from my perspective. But I will definitely write one more because in the end it was fun, although it was a lot of work. I should say that for now I rather talk other people into writing books. So I've read the book from Frances Buontempo, Learn C++ by Example. And I actually was quite amazed. I really liked the book because she talks about this language in a very positive way. She shows examples that are, well, safe and fast and simple because she uses the way that C++ should be used today. And also it was entertaining to read because of the games she talks about. So I think in almost every chapter she wrote another game. word smash, and this was fun indeed. And so because she kind of managed to write this book, just showing the positive aspects, I was asking her to write a book, a beginner's book about C++. And yeah, I've convinced her. She's done that, or she is doing it right now. She's done with all the chapters.
We spoke about that in the interview.
Okay,
So.
perfect. So I talked her into this, and Kevin Henny at NDC TechTown and told me that her favorite saying nowadays is, "It's all Klaus's fault."
That's it.
I think that by doing that, by letting other people write books, I also kind of contribute to the community again. Yep. Hopefully, a little bit.
Yeah, I got kind of worried that the book you mentioned was chapter 7 was hers, but
no. She does a good job, and really made sure that she talks about the safe things. Yes, she does talk about pointers too eventually, but first she shows the safe things. That's the things that just work, where you do not have to think about out of bounds access and undefined behavior. It just works, and and people that read that book hopefully later will be able to write C++ in a way that's not dangerous at all. No, it wasn't her book. Absolutely not.
And as a personal question, how do you learn C++? I mean, you must learn C++ yourself too, because,
So just because I do public talks does not mean that I know everything. Oh, definitely not. Far from it. I've big gaps because I did not do everything yet. But I constantly learn by watching talks from conferences, by going to conferences, by, talking about things that I might not be mastering yet. So I also have to learn about this a little bit. So I spend, say, an hour every day at least to learn about C++. So I actually think this is a good percentage. And actually comes close to what Robert Martin in his Clean Coder book suggested. Invest 1 hour per day to, invest 1 hour every day into yourself, to learn more about your profession. I think this is what I do. I should also say that it's not just videos that I watch. No. You see that I have a lot of books behind me. When there's a good book, a new book coming out, I usually order this quickly. I read the book. So, one of the newest books is C++ Memory Management from Patrice Roy, which I would definitely recommend to many people. This is one of the good books. It's not difficult. It gives good examples. It's a good read, and it's fun. So learning about a little more C++ is fun usually. Can just recommend that.
That's true. And it's similar with me. Just made a little video yesterday about implementing a feature, and I ended up implementing it like 3 times because I had to implement it 3 times because I had to record it 3 times.
Okay.
Because that's just something that I'm not so used to.
You really know about this? Yeah, doing it 3 times.
But I already learned.
Right?
Yes, I got from 10 minutes to 5 minutes down in the editing, and the first video was 10 minutes after the editing, and I learned a lot about also like video recording, something like that, and that's also like a learning curve.
See,
first recording I liked very much, but then I figured out that the code was way too small, that I should scroll in the code and video setups, etc. But anyways, this was really a nice interview with you. I'm really looking forward to see you at the conference. If you have any more questions, then
now is a good time. Yeah. Then at this point, let me already say thank you for the invitation. It was a pleasure indeed, and I really look forward to the conference this year. Yeah, I kind of expect that will be a really amazing meeting of C+ enthusiasts again. 5 tracks, not just 4 like last year, but 5. Oh yes, that's nice. And I actually I expect that there will be a couple of really good talks this year. I've not the entire program in my head, but I've seen a couple of. I remember a couple of talks. I've seen that we have great keynotes this year too. So I believe it will be a really good conference. So if you can in any way make it to Berlin in November, do so. It's definitely worth the time and effort.
Yes. Yeah, it's like one of the recent interesting results is the attendee survey,
Mhm.
to where every attendee only has 15 talks they can choose from all the tracks. Except, I mean, it's only the on-site tracks because I want to know which talks should be in the bigger rooms, and at least that's what people think. But actually, the survey is about who's on the bottom and gets to be in the smallest room.
Okay.
Which Klaus is very happy that he is not anymore in the smallest room.
Yay!
Like the one thing which surprised me is like that, and I have to be very restrictive with a big room, that
Sure.
I can't just now say, well, that's a new schedule which we created through this tool. That's not going to work.
Absolutely. Makes sense.
And right now we have 60 people who have taken this survey, and it's really only attendees, not speakers. And next year I'm probably going to be prepared to also send this to speakers. But also, I don't want to mix up those result sets. I want to be able to filter for attendees and see like what speaker's opinion is.
Mhm.
But what I found interesting is that under those attendees now, the talk which made it in the main track is actually the introduction to Rust. And more than 50% of those folks which have, taken the survey. And on the top is your talk, and it's, I think, right now 68% or something, which I find rather interesting. And yeah, this is really interesting what you do as, in teaching. And I think we have a question. LinkedIn is back, and indeed, see it works. So Ivan from LinkedIn asks, "Hello, Klaus. Any advice for a freshman professor aiming to motivate his students on learning C++?"
So the one thing that I try to do in any of my training classes, whether it's online or on site, is to carry a lot of enthusiasm with me. So I do not just talk about this, but I try to show that I'm excited about this, that I like what I do, that C++ is awesome, which it is. So it's not pretending. It really is just a heartfelt feeling. But if you carry this feeling with you in these training classes, and if you show the enthusiasm and the excitement, then I believe this helps to motivate the student to continue learning C++, for sure. If you are excited about this, really excited, honestly excited, then people will just carry on this excitement and continue. So now, I don't know if this is good advice because I can sell this well because I am really excited, and I do like teaching. Therefore, it feels good and it's easy for me. But I believe you can you can try this as well. Yeah, this will definitely help.
Yeah, we recorded today the talk from with the professor and two students actually from the University of Vienna, Helmut Hellwachs, and so he probably is someone you should reach out to because he also teaches C++ and they teach it with games and they have their own entity component library. And that's what they talked about. And they had like one or two other talks which were not too popular. Actually, that's a great pivot to another topic because the one topic that has not been totally popular with the voting, and generally this year has been, take a guess, AI.
That's a
So
good
I
good question. First final question. I don't know.
Mhm.
So my view has changed a little bit. Initially, I was a little suspicious about that. I was not really sure whether this was a total hype or if there's something behind this. But I believe now, I believe there is a lot that these AI tools can do for us. So now, don't get me wrong. I don't think these tools should write our code. No, I don't think this is where they are good enough yet. But By now, I know that these AI tools are actually very good at writing the documentation for you. This is what they truly can do well. They reasonably well understand the code, compare this with so many other things that I've seen before, and I can pretty much, pretty easily create the documentation for you. And that is really a help for your productivity. You should not just accept the documentation. So don't click on generate and then you leave it. No, of course you read through the documentation, you improve it, but you have a starting point. And this is what is so difficult for many people, to just get started with the documentation. Now you have something already and you can continue to improve it. Saves so much time, really good. Then what AI tools can also do reasonably well, my experience is they can explain the code to you. So if you have a medium-sized piece of code, and you don't even know where to start, you can actually just tell the AI, explain that to me, and it actually works pretty well. Yeah, this AI can actually give you also an idea where to start. This is something that I believe we've been missing before. So good use of AI tooling. AI tools can also write code for you, of course. This is why I would be very cautious, really cautious, because so if you have a for loop and say, please make an algorithm out of this, that works well. Really, this is simple. This has been done millions of times before. This is what AI can do well. But if you want to just write a little more code, bigger code, perhaps code that is new, this is what I cannot do well yet. As long as you can automate this stuff well, AI is a good, really a good support. But going into new territory, this is, well, just based on how AIs work, what they cannot do well at all. So use it for the things I said they're good at, but be wary of code generation yet. Something works well, yes, but not everything.
Yeah, my view is kind of reshaping at the time because the tools are getting better.
Indeed.
But also, I think that on the other side, it doesn't know what it's doing, right? It's just trained to give you the output you'd like to see.
Yeah,
And that's kind of
we call it AI, but there is no real intelligence. It's all good databases, good combinations of things, and repeating the things it has seen millions and millions times before. This is why training an AI is so important. But no, it's not about intelligence, not really. It's not this understanding of what it's doing, as you said.
All right.
Good.
Do you know about profiling toolings?
Oh, there are many, but
because I think
my favorite profiling tool. Okay, profiling. I mean, there's the simple ones that you get for free. For instance, there is the gprof tool on Linux mostly. There is something that I know from my own university called Liquid, LEKWID. That is a good tool. And of course, anything that allows you to annotate the code. This is for free. This is usually simple. This is good. I don't know if I can say this is my favorite profiling tool. Favorite is probably more the tools that do cost a little bit. VTune was quite amazing when I had the chance to use it for a while. So any tool that comes with more support for IDE support, etc., is quite useful. But I generally advise you to look into tools that provide heat maps. Which function is called most often? Where is most of the time spent, the resources spent? This is something that helps a lot to get an idea what you really should profile. Not profiling everything is usually just too much, but getting this idea, where's the hot stuff? Yeah, the hot path, the hot function that is called often that takes too much time. This is where heat maps can help.
Yeah. KDAB has an open source tool which displays flame graphs from your code. So
There's flame graphs, exactly. Yeah, that's a nice visualization of that. Yeah.
But I don't know you as a tool guy, so is my impression there right? Or will you write a book about tooling that one day?
No, I'm not a tooling expert. I'll not write a book on that.
All right.
Then thank you, Jens. It was a pleasure to see you again. And I really look forward to see you in person on Meeting C++.
Indeed. Thank you for your time.
Thank you, everyone.
Yeah. See you in Berlin.